Taking what we've learned about angles in the coordinate plane, standard position, reference angles, and coterminal angles, we're going to extend that to trigonometry. In trigonometry, we have a reference angle. Let me get this to work. A reference angle formed with the initial ray, terminal ray, at a point on the coordinate plane, which forms a right triangle that we can use our trigonometric ratios to find. Remember from a couple of weeks ago, your trigonometric ratios. Here's your angle, and here are sine, cosine, tangent, and their reciprocal identities, cosecant, secant, cotangent. We're going to use those with a point in the coordinate plane to form a right triangle with our reference angle being from the origin. So here's an example down below on how we do that. Find the 6 trig ratios at the point -4, -6. Step 1 is to actually plot -4, -6. So plot that point. Then you form the terminal ray from the origin to that point. That gives us a reference angle from the origin up to the x-axis here, and it gives us a triangle which you take a perpendicular up to the x-axis, that gives us that right angle, and back over to the origin. Now that we're in the coordinate plane, though, this triangle can have negative side lengths. This side length is -4. That side length is -6. Hold on. And if you use the Pythagorean theorem, remember, leg squared plus leg squared equals hypotenuse squared, and simplify that radical, we get that the hypotenuse is 2 square roots of 13. If theta is the reference angle, that makes -6 opposite, -4 adjacent, and the 2 square roots of 13 the hypotenuse. Form those trig values then for theta. Sine of theta, opposite over hypotenuse, but that needs to be simplified. We need to simplify it by multiplying by the square root of 13, top and bottom, and also simplifying -6 over 2. That gives me -3 square roots of 13 over 13. There's our sine value. Our cosine of theta is adjacent over hypotenuse, -4 over 2 square roots of 13, and get rid of square root of 13, top and bottom, simplify the fraction of -4 over 2, and I get -2 square roots of 13 over 13. Tangent, SOHCAHTOA, tangent of theta is opposite over adjacent. Simplify that fraction, and we get 3/2. They're reciprocal identities. We just need to find the reciprocal of these values. The cosecant of theta is the reciprocal of sine. That is 2 square roots of 13 over -6. Simplifies into the negative square root of 13 over 3. Secant of theta is the reciprocal of cosine, so 2 square roots of 13 over -4, which is the negative square root of 13 over 2, simplified. And finally, cotangent of theta is the reciprocal of tangent, so -4 over -6, which is positive 2/3. And those are the 6 trig ratios at the point -4, -6 by drawing that triangle that I described.